Crab Nebula. Crab Nebula, probably the most intensely studied bright nebula, in the constellation Taurus, about 6,500 light-years from Earth. Roughly 10 light-years in diameter, it is assumed to be the remnant of a supernova observed by Chinese and other astronomers first on July 4, 1054. The supernova was visible in daylight for 23 and at night for almost 2 years. In 1758 it was the first object listed, M1, in Charles Messier's catalogue of nebulous objects. It acquired its name, suggested by its form, in the mid-19th century. In 1921 it was discovered to be still expanding. The present rate is about 1,100 kilometers, 700 miles, per second. The crab is one of the few astronomical objects from which radiation has been detected over the entire measurable spectrum, from radio waves through infrared and visible wavelengths to ultraviolet, X-rays, and gamma rays. In the late 1960s the crab pulsar, thought to be the collapsed remnant of the supernova, was discovered near the center of the nebula. The pulsar, which flashes in radio, visible, X-ray, and gamma ray wavelengths at 30 times per second, provides the energy that allows the nebula to glow. Classes of nebulae. All nebulae observed in the Milky Way galaxy are forms of interstellar matter, namely, the gas between the stars that is almost always accompanied by solid grains of cosmic dust. Their appearance differs widely, depending not only on the temperature and density of the material observed but also on how the material is spatially situated with respect to the observer. Their chemical composition, however, is fairly uniform. It corresponds to the composition of the universe in general in that approximately 90% of the constituent atoms are hydrogen and nearly all the rest are helium, with oxygen, carbon, neon, nitrogen, and the other elements together making up about 2 atoms per thousand. On the basis of appearance, nebulae can be divided into 2 broad classes, dark nebulae and bright nebulae. Dark nebulae appear as irregularly shaped black patches in the sky and blot out the light of the stars that lie beyond them. Bright nebulae appear as faintly luminous glowing surfaces. They either emit their own light or reflect the light of nearby stars. Bright nebulae are comparatively dense clouds of gas within the diffuse interstellar medium. They have several subclasses. 1. Reflection nebulae. 2. H2 regions. 3. Diffuse ionized gas. 4. Planetary nebulae. And 5. Supernova remnants. Reflection nebulae reflect the light of a nearby star from their constituent dust grains. The gas of reflection nebulae is cold, and such objects would be seen as dark nebulae if it were not for the nearby light source. H2 regions are clouds of hydrogen ionized, separated into positive H+ ions and free electrons, by a neighboring hot star. Diffuse ionized gas, so pervasive among the nebular clouds, is a major component of the galaxy. Planetary nebulae are ejected from stars that are dying but are not massive enough to become supernovae, namely, red giant stars. Supernova remnants are the clouds of gas expanding at speeds of hundreds or even thousands of kilometers per second, from comparatively recent explosions of massive stars. If a supernova remnant is younger than a few thousand years, it may be assumed that the gas in the nebula was mostly ejected by the exploded star. Otherwise, the nebula would consist chiefly of interstellar gas that has been swept up by the expanding remnant of older objects.